If you watch enough science fiction, you might think the biggest danger in space is simply the lack of air, a quiet, empty vacuum where you'd float around and try to hold your breath. But the actual planetary real estate, the moons, planets, and stars, presents a hyperactive gauntlet of physics that makes a simple lack of air look like a minor inconvenience. We're talking about environments with crushing atmospheric pressures, temperatures sitting near absolute zero, and radiation levels that can tear apart your DNA in a matter of minutes. To understand the lethality of the cosmos, we are mapping the deadliest environments in the known universe, organized by exactly how much time a human body has left to survive the moment it's exposed. We start the clock at the very edge of our solar system, in the Oort cloud. Out here, the temperature sits at minus 450 degrees Fahrenheit, and you are surrounded by trillions of miles of dark, silent emptiness. Even Voyager 1, the farthest object humans have ever launched, has traveled for nearly 50 years and still hasn't reached the inner edge. Stranded in the cloud, nothing kills you fast. Assuming your ship's hull remains intact, you would wait for months in total isolation for your rations and oxygen to finally run out. Moving closer to home brings us to the moon. Here, the survival timeline shrinks from months to just a few days, dictated by the jagged nature of the lunar surface. Billions of years of meteor impacts have pulverized the surface into a fine powder. Because there is no wind or water to erode the particles, every grain is a microscopic, jagged shard of glass. These shards are small enough to slip through filters and stick to everything you touch. Once brought inside a habitat, you breathe them in. Over a few days, those microscopic edges shred your lung tissue until you lose the ability to take in oxygen. As we move into planetary atmospheres, that timeline drops from days down to a handful of minutes. That is all the time you have on moons like Titan or Europa. If you fall into Titan's liquid methane lakes or plunge through Europa's icy shell, you wouldn't float. Liquid methane is half the density of water. You would sink straight down and freeze solid before you had a chance to drown. On Mars, the near-zero air pressure causes the liquids inside your body to start boiling the moment your suit fails. This comparison shows the difference between Earth's air and the atmosphere of Venus. With a composition of 96% carbon dioxide, the air on Venus is 92 times heavier than what we feel at sea level, enough to crush a standard suit almost instantly. Farther out, the exoplanet HD 189733b experiences weather where rock turns to gas and then cools into glass shards. Those shards get caught in winds blowing sideways at over 5,400 miles per hour, roughly 7 times the speed of sound. In these environments, engineering and specialized suits only buy you a few brutal minutes before the sheer physical force of the environment overwhelms the materials. Now we enter realms where your timeline is measured in fractions of a second. These are places where destruction moves faster than your nervous system, starting with the plasma layers of the sun. NASA's Parker Solar Probe represents the absolute limit of our current thermal engineering, and only managed to get within 4 million miles of the surface. If a human reached the surface, your suit would char in 1/10 of a millisecond. By 10 milliseconds, your flesh, bones, and gear would all be converted into gas. You would be gone before your brain could register a pain signal. A supernova release takes this further. When a massive star explodes, it emits a wave of radiation traveling at the speed of light. Because it moves at that speed, there is no way to see it coming. By the time it's detectable, it is already breaking apart every atom in your body. The most extreme physical distortion comes from a magnetar. This is a hyper-dense core with a magnetic field up to a quadrillion times stronger than Earth's. From thousands of miles away, this field grabs the normally round atoms in your body, violently squeezing them into long, thin, needle-like shapes. Once deformed, the molecular bonds holding your DNA together stop working. Your body dissolves simultaneously without anything visibly touching you. Finally, there is the black hole. As you approach the event horizon, the pull of gravity on your feet becomes so much stronger than the pull on your head that your body is stretched into a thin stream of atoms. Scientists have called this process spaghettification. At these ultimate extremes, the laws of physics effectively erase the human form from existence before the mind is even aware the end has arrived. Pulling back from the black holes, the magnetars, and the supersonic glass storms reveals the isolated scale of the pale blue dot. We require a very narrow set of parameters, specific pressures, temperatures, and magnetic shielding, just to sustain our biology. A slight shift in any of these variables results in immediate failure. The cosmos is an environment explicitly hostile to our biology. Earth is a miraculous, fragile oasis in a universe governed by forces that are physically incompatible with our existence.